Hello, Math 2 students. This is going to be some notes on and some little bit of practice on measures of center and measures of variability, looking at box plots or dot plots. Also, I'll talk about what an outlier is, right? So I'm going to flip it around. Here we go. So the measures of center are mean, mode, and median. Mean, do you remember how to find mean? That's right, it's the total divided by the number of numbers. It's actually an equation. And then mode, you remember how to find mode? And yep, it's the most often, and you can have more than one mode, and you can also have no mode. And then the median, you remember how to find median? And yeah, you got to put them in order, and it's the number in the middle. Median means middle, but you got to put them in order, right? So let's skip this for now. Let's say I had this box plot, which is, say this is the below is a box plot for height of plants grown using fertilizer X. And so I took all the data and I made it into this box plot. So the minimum is almost 10, maybe 11. The maximum looks like it's about 50. And then the median would be right there, about 25. And then the quartile 1 is 20 and quartile 2 is 30. About, all right? So say I just want to do measures of center from this. What's an inference I could make? Well, of the measure of center from a box plot, the only one of these you can find would be, that's right, the median. You can find the median from a box plot. It's right there in the median. So an inference you could make is, oh, the median for the plant height using fertilizer X is 25. And that would be a statement you can make based on facts, right? The median plant height using fertilizer X would be, the median's 25, right? Now what if I wanted to make a measure of variability? Or I want to make an inference about the measures of variability. Well, range, let's go over these three. Range, that's a formula. That's the range equals the max minus the min. And IQR, that's also a formula. That's Q3 minus Q1. And then MAD is just going to be a number they'll give you if they give it to you, which means the mean absolute deviation, which actually means it's the average of how far each number is from the average. So the bigger the MAD, the bigger the variability, or the smaller the MAD, the smaller variability, or we just say the greater the consistency. So here's the statements I'd like you to actually, you want to get this down. As each of these numbers gets bigger, the variability gets bigger. And then as each of these numbers gets smaller, the consistency increases. Now, if you're looking at a box plot, what can you talk about as far as measure of variability from a box plot? Well, I didn't give you the MAD, that'd just be a number, so you can't do that. You can see the range from a box plot. The range is 50 minus about 10, so the range is about 40. And that's a fact, that's a piece of data you could get. The IQR is Q3 minus Q1. 30 minus 20 is 10. So you could say the IQR, you could show your work, the IQR is about 10. And so inferences you could make is, well, the range for the heights of plants using fertilizer X is 40. Another inference you could make, the IQR for the height of plants grown using fertilizer X is 10. That's just a statement, that's a fact, statement of fact you can make based on data. And those are the statements you would make if you're talking about measures or variability. These are just singular things. You're not comparing. I'll do that in the next video when we compare two box plots. But I'm just making an inference and just a statement of fact based on data. The range is 40, the IQR is 10. Those would be things of variability, all right? And then down here, so say I have this dot plot. And let's just say it's, again, say fertilizer Y or whatever, doesn't matter. So here, if I was describing this, I'd call this bimodal. You have this cluster right here. I have a cluster of, at 9 and 10 of, you know, seven pieces of data. And then like at 19 and 20, I got a cluster again of like 8 numbers here. I'd call this distribution bimodal. This is a bimodal distribution. It has 2 peaks. Now the mode, you could talk about the mode. The mode is 10, 19, and 20. Isn't that your mode? You could say the min is 5 and the max is 40. You could say the range is 35. As far as measures of center, the easiest one to find would be the median. Here you got 7, here's 8 numbers, 9, 10, here's 10 numbers, and then here's 8, 9, 10, here's 10 numbers. So there's 10 numbers to the left of that, and there's 10 numbers to the right of that. This dot right here is in the middle. That's like at 16 or 17. The mode, or the median, is like 16 or 17. That's the median. And that would be your best measure of center, because this number way out here has a name. It's called an outlier, because it's way away from all the other numbers. And this one has no effect on the mode. The mode stays 10, 19, and 20. But it's going to have it's going to have an effect on the mean, isn't it? Isn't that going to make the average higher? And it's going to have hardly any effect on the median. So your median would be the best measure of center here when you have an outlier, when you have a number, you know, really big number or really small number, it can throw the average off. And so median is your best measure of center. All right. And then as far as talking about if you're talking about variability here, you could say, oh, well, my range is 35, and that's, you know, I wouldn't want to, you'd have to make this into a box plot to find your IQR, and that's a lot more work, actually making a box plot. I showed you how to do that last week. But anyways, from this, if you're talking about give me a measure of variability, I would say the range is 40 minus 5. The range is 35. That'd be your easiest measure of variability to talk about. So hopefully that was helpful.